Hello friends, welcome to a new session on section of solids. This is Professor Rajesh K. Behera from AP Shah Institute of Technology. Before starting off the new problem, let's read it out. The question: a hexagonal pyramid, side of base 40 mm and axis length 70 mm is resting on its base on HP with two base edges perpendicular to VP. It is cut by an AIP with 60 degree and passing through a point on the axis 40 mm above the base. Draw front view, sectional top view and true shape of section, that is TSOS. Now once again, if we start reading out the problem, we'll note down the important parameters. A hexagonal pyramid, a pyramid with the base hexagon is there. Side of base, that means each base edge is of 40 mm and axis length, that is the height of the pyramid, is 70 mm, is resting on its base on HP. That means in top view we will able to see hexagon because the base is resting on HP with two base edges perpendicular to VP. Important part of the object is base edge, which has been mentioned here. So this particular part has to be taken on right hand side. It is cut by an AIP. The moment we see the introduction of cutting plane line, whatever the position of the object is defined before that is a complete position. That means no further change in the position of the object will take place. So it is cut by an AIP. AIP means auxiliary inclined plane with 60 degree. That means this particular angle is with respect to HP. So we can see a cutting plane line in front view and passing through a point on the axis 40 mm above the base. So draw front view, section top view and TSOS. So this is the understanding of the statement. Let's start with the actual solution now. First we'll draw a circle, radius of which will be equal to the base edge. Base edge is given as 40 mm. So we'll take in a compass, we'll take 40 mm, we'll draw a circle of 40 mm. And since we have to take base edge on right hand side, from the top we'll draw two center lines. From the top we'll keep an arc of the same radius. We'll cut an arc on both sides, and similarly we'll cut an arc on the circumference. So we'll join these points and we'll get a hexagon. This has to be drawn by construction line. Since it's a pyramid, so all slant edges will come at the apex From there we'll take all the points in upward direction and we'll get our points in the front view. We'll write down the important part. This will be A, B, important edge been named, then C, D, E and F. Apex will be named as O, and the lowest point, the bottom point of the axis, as O1. We'll transfer these points in front view. Here we'll get A dash, B dash, this will be C dash, then T dash, E dash, again coming back to this point, it will be F dash. We'll write down the dimensions Same time, if we write down the dimensions, it will be easy for us to trace all the points properly. This is 40 in front view. This will be O, this will be O1 dash, this will be O dash. We'll connect by construction line. First we'll draw all the outlines, then we'll take care of the points which are lying inside. From here, the observer see this. The observer can see this particular corner, that is C. So all the three edges coming from C can be visible. So C to B. So C to B already it's a part of the outline. C to D. So C to D is already a part of the outline. C to O can be seen. So it will be drawn by a visible line. Again I am repeating, this all are by a construction line. I am making it a little bit dark so that it is visible for you. Then we'll write down the dimensions for the height as mentioned. Height is mentioned as 70. So again read out the problem. A hexagonal pyramid, side of base 40 mm, axis length 70 mm, both dimensions has been taken care. Base on HP, so top view is a hexagon with two base edges perpendicular to VP. So two base edges, this base edge and this base edge is perpendicular to VP. It is cut by an AIP with 60 degree. So we'll take an angle 60 degree and we'll pass the cutting plane line. This 60 degree can be passed from here also, here also, here also, and here also. So there should be some limitations given. So, and passing through a point on the axis 40 mm above the base. So this another limitation is given. So this inclination of the cutting plane, that is AIP, is 60 degree, but also it is passing from the 40 mm from the base. So we'll measure 40 mm from the base, from here till here 40 mm is coming. So we'll first locate 40 mm. And from here we'll pass cutting plane line at an angle of 60 degree. Representation of cutting plane line, already we had seen, it is always a big dash, small dash, big dash, small dash, with extreme big dash are been thickened and direction of observer is shown. Angle will be mentioned as 60 degrees. Once we pass this cutting plane line, this above part which is nearer to the observer will be removed, and the lower part, this part, will be retained. So first we'll write down whichever the new edges we had got or corners, we'll name them. It is cutting here the base edge. Now this base edge is not a single base edge. It is C to D and E to F. Two base edges are involved, right? So here we'll start writing down the name. We'll start from top, OA and OB. So here it is 1, right? Then OB comes the second edge, 2. Then OC comes the third edge, 3. Then after OC we have OD, but it is not cutting that OD, neither it is cutting OE. It has been already removed. So we come back and we see this base edge has been cutted. So C to D will be 4. One more base edge is there at the back side, that is 5. Will come back here to OF, it will be 6. Same points will transfer OA. We have OA. Now while transferring the points, we have to take care that slant edge point should be transferred on the slant edge view only. That means these are the slant edge. So point on that slant edge should be transferred in the top view on slant edge only. So 1 will be on here, OA. 2 will be on OB. So write down here 1, 2, 3 and 6 will take care later on. First here 4 and 5. 4 and 5 are on base edge. So this point should be transferred on base edge. So 4 is the point which is at the front side. 4 and here it is 5. Right. So we had transferred slant edge points on slant edge, base edge points on base edge. Now see here 3 and 6. If I transfer this 3 and 6, it will directly come here and will not get any intersections, right? Because it is on a vertical line. The entire it is coming on a vertical line. In such cases, we have to take it, we have to project this 3 and 6 on the true length, right? And then we have to project in downward direction. For that, I have to rotate, I will have to rotate OA or OB. So if I rotate OA in this direction, I will get a new point. I will just name it as A1 dash, just for the reference, right? So now OA1 dash is the line, slant edge, new slant edge in the top view. I will transfer here. And here I get A1, right, dash, the same thing, same, intentionally I am keeping the same notation. So if I connect this new point, please see here now, in projection of lines, we see if one of the line is inclined in one view and the other view, if we are having a parallel line with respect to xy, then this inclined line will always be a true length. In projection of lines, I repeat, we had seen if one view shows a line is having an inclination and the other view of this line shows parallel to xy, then this inclined line is always a true length. Here we are having A1 dash as a true length because the other view of this true length is parallel to xy. So we can now project this 3 and 6 on true length. We cannot project through apparent line because here OAB, right, OA or OB is inclined and the other view of OA dash and OB dash is also inclined. So we cannot transfer those points through apparent lengths. We have to use true length. So I will take this 3 and 6 on true length, and from true length I will transfer the points on the plan lengths. Please see here, please make a note. I transferred on OA1 dash. This I got by rotating A. From here, I will again rotate this point So what I done, I transferred these points so what we have done, we have taken this 3 6, we have transferred it on the true length, we have brought it down on the this horizontal line of OA1 dash. We have rotated it by taking the same radius from here, and here we got now 2 points. Already we had 1 2, this will be 3 4, already we have 5, and this will be 6. This is all the points on the top view. We'll connect them sequentially. This will be by dark line. So I'm using a red color for all the visible lines, visible and dark line. And all the lines which I am drawing by black pencil are either medium dark line or construction line. Okay, so see, this is the shape of the sectional top view which I am getting here, right? Which part has been removed now? This part has been removed from the front view. In top, this much of part has been removed. So retained part will be by visible lines. So retained part by visible line. So this is the retained part in front view, and in top view this will be the retained part. First I am targeting all the base edges. Now apex has been removed. So here in top we will not have an apex, but we will have a slant edges from 3 to C. See here, 3 to C is retained. So in top view also 3 to C will be continuous line. Then 6 to F is retained. So 6 to F will be dark line. 1 to A is retained. So 1 to A will be retained line. 2 to B is retained. So 2 to B will be by continuous and dark line. This is the top view. We will have to go for sectioning. Sectioning, we always draw a 45-degree line at some gap. Uniform spacing is there. I'm drawing by a scale freehand, but students are expected to use drafter with set squares. This is sectional top view, right? This is sectional top view. Front view already we had seen. Now we want to draw true shape of section. We already have seen draw front view with retained part and removed part is been drawn. Sectional top view. This is a sectional top view with retained part and removed part and sectioning, right? Then TSOS, that is true shape of section. For that simply we are doing what? We are drawing. In the previous lecture we had seen, we had taken the true shape of section in this direction. I am showing you one more method of drawing true shape of section. We will just make this section line, cutting plane line, as a horizontal line parallel to XY. Again, similar fashion, half of the bigger dash will be thick, since we will look from this direction in downward direction, so half of the bigger dash will be thick with an arrowhead. Now any one side we will locate 4 and 5 point, and then we'll measure all these distances and we'll mark on it from 4 and 5, and from again 4 and 5, 3 and 6 distance. So this is 3 and 6, and this particular part is 1 and 2. Here we'll draw by construction lines. We'll take all these points in downward direction, and from top view we will take all the points towards left hand side. So again we will get a matrix. Again I am repeating, I am drawing by a scale directly. Students are expected to use drafter with set squares. After getting this matrix, simply we have to write down this is 1, wherever 1 gets intersected with 1, it will write down that one. 2, this will be 3, this will be 4, sorry, here 5, and 6 is here. Until we connect them by a continuous and visible line. And again we will draw sectioning lines, that is hatching line at an angle of 45 degree. Space should be uniform. Here we'll write down. Generally it is expected to write it down for a better impression also. True shape of section. So see here, whatever the things were been asked, draw front view, sectional top view, TSOS, that is true shape of section, we have completed the entire one. Sometimes this is now an optional one. Sometimes they may ask you for sectional side view also. In that case, we simply take front view, top view. We simply take all the points here. We draw a 45-degree line. We'll take all the positions along this 45-degree. We'll take it in upward direction. Similar way, from front view, we'll take all the position on the right hand side and we'll draw our front side view now. So we'll just transfer all the points first. Now since these were on slant edges, directly we had transferred this one, but we cannot transfer the base edges. Base edges points has to be transferred using base edges, this one, 5 and 4. So we'll take this 4 and 5 on this 45-degree line. Similarly for 4, from here transfer it in top view. Sorry, side view. Now we'll just first write down all the points. See here, this F. First we'll look at this apex. Side view we go for double dash. Now this F has been transferred here, so we'll got here F double dash. Then E and A will coincide. So here it will be A double dash and A double dash, this point. Then D and B will also coincide here, so we'll get D double dash, B double dash. C will come here and will go and meet on this point as C double dash. Right now also see here 1 and 2 is on OA and OB. So OA is here, so here we'll get 1. OB is here, so here we'll get 2. Then 3 and 6 is on OC and OF. So on OC it is 3. This is C. So on OC we'll get 3. And on OF we'll get 6. Then 5 and 4 will come on this base, but we are taken from the top view from the true length. So this will be 5 and 4 we are taken here in this direction, 4. Now we'll connect by a visible line, 1 to 2, 2 to 3, then 3 to 4. First we always go with sequential one, then we'll take care of the retained pyramid and coming back from 6 to 1. This is a sectional side view, right? Still to be completed. Then apex part has been removed. What is retained now in side view? F dash, see here, F double dash, it is there in front view, it is retained part. So here from 6 till F dash will be retained part. Similarly 3 to C is also retained, so 3 to C will also be retained. So 3 to C will be retained, and F to C is entirely retained in front view. So here also this part will be clearly seen. So now sectional side view, again at an angle of 45 degree. We'll draw sectioning line with uniform spacing. Red lines in my problems means visible dark lines, and black lines which I have drawn by pencil in my problem are construction lines for you. This I had used so that all the lines are visible to you. This is sectional side view. So we had drawn front view, sectional top view, true shape of section and side view. I hope you will understand how to draw sectional of solid of hexagonal pyramid with the data given to you. If you have any query, please write down in the comment box. Thank you. Let's meet for the next time.